Hi everyone, my name is Carlos. Today I'm gonna talk to you about one of my favorite topics, and it's the nanotechnology. Well, today we're gonna explore how the very small things can change entire industries, and it's in all the world. My goal is simple: understand what nanotechnology is, understand where is the application of the nanotechnology, and how can make it and measure it, and where is used in the world. Okay, let's gonna start with the most important thing that you have to know, and is what is nanotechnology. Well, nanotechnology means manipulating matter between 1 and 100 nanometers to unlock new properties. What is a nanometer? Later in this presentation, I'm gonna give you an example about that. Well, it's not just making things smaller. Well, at this scale, quantum effects appear, and surface area dominates the these effects. It's a very multidisciplinary field because in nanotechnology you can see physics, chemistry, biology, and engineer, and all these areas working together. Okay, let's continue with a very important thing that you have to understand, and is what is a nanometer. That's why we have the nanometric scale. Well, 1 nanometer is a billionth of a meter. In this image, we can see a very good example of the representation of what a nanometer is. What is the measure of 1 nanometer? Imagine that you have an apple. The apple is 1 nanometer, and the entire world is 1 meter. That is the magnitude of what small is a nanometer. We can continue with more examples like DNA. It's about 2 nanometers wide. Many virus range from 20 to 200 nanometers. Or another example is that cells are the 10 to 100 micrometers, and a bacteria is around to 1 to 2 micrometers. 1 micrometer is 100 nanometers. We can see a very important things about in our cells, our body, our DNA, and that's why nanotechnology is important. We can work with cells and biology and things like that. Okay, let's gonna talk about the properties. Before I said that nanomaterials have different properties. And why is that? That's because um, if I have a material in a very small size, acts different like as a normal material. That's because in a very small scale we have quantum effects. Just the materials work different. There are not the same rules that the normal materials. And also we have a big superficial area, and that thing also give us different properties. Okay, let's gonna start with some examples like quantum dots. The quantum dots is the image that we have at the left side. In summary, quantum dots change color depending on its size. Depending on the size of the particle, we're gonna have a different colors, and the quantum dots are used in for example, the TVs. Other example is the graphene, is the image of the center. That material have exceptional strength to weight. Another example is the gold and silver nanoparticles, and that show a strong plasmonic interactions with light. That materials have a lot of application that let's gonna see in this presentation. And how we can make nanomaterials? Well, to make nanomaterials we can take two ways: the top down and the bottom up. Basically, the top down starts from a large or macroscopic material and decomposes or reduces until reaches a nanometric size. In summary, we can take a big material and we decompose it, we separate it, reduce it until we have a nanomaterial. This is the top down. And in the bottom up is the basis of the process, where molecules or nanoparticles are created and produced that will be used to form larger and more complex materials. In summary, we can take atoms, composes, and elements, and with that elements, that with atoms, we can, I can say, put it together. And if we do that in the right way, with a good formula, we can have a nanomaterial. And that's the ways that we can make nanomaterials. And now we have a very important question. How can I measure it? How can I know that I have a nanomaterial? That I make well my nanomaterial. That I make my synthesis good. That's why we have different type of microscopes to know that things. The first example is the AFM, that is Atomic Force Microscope. This microscope scans surfaces with a tiny tip to map the topography at the nanometer scale. For example, I have my material and we have a tip that are making a map for my material. That's why I can know the topography. I can know the shape of my material. And the tip register all the surface of the material. It's very interesting. And I also have the SEM and the TEM. These microscopes are similar. SEM is scan electrons microscope, scanning electrons microscope, and TEM is tunnel effect microscope. These microscopes use electrons to reveal morphology and internal structure of my nanomaterial. The last one is the XRD, that is X-ray diffraction, and with this method I can know the crystal phases and the domain size. Summary is used to know what type of materials or compounds are made by nanomaterials. And yeah, that's how we can measure it. And know another thing, not only measure it, know different properties, the morphology, the shape, and things like that are very important to know the properties that gonna have my nanomaterial. Okay, let's gonna pass to another section, that is the applications of nanotechnology. As we said, nanotechnology is a multidisciplinary science. We can work with the biology, the physics, the engineering, genetics, and work with all these areas. They are very multidisciplinary, and that's why we can have a lot of applications. It's gonna talk about some applications, but there are more. Let's start with the health applications. In this presentation, let's gonna talk about three, and let's start with one of the most important applications in health, that is targeted delivery. Nanoparticles deliver drugs to a specific tissue. What's that? The targeted delivery summary is, imagine that I need that medicine. We have to deliver a medicine to a specific part of my body. For example, the brain. If I want to deliver a medicine to the brain, is with targeted delivery, and the nanotechnology is very important in this application. With nanotechnology we can do that. Another application is the diagnostic and imaging. One example is the quantum dots, that contrast agents improves sensitive. And another example, and it's very important, is the glucometer. The glucometer it's made thanks to the nanotechnology, because we can make the sensors of the glucometer with nanotechnology. That's why in diagnostics is very important, the nanotechnology. And in the future, it's gonna be essential. And the last one in this health application is regenerative medicine. Nanotexture scaffolds get cell growth. Yeah. Okay, that's gonna talk about energy and environment applications. One of the more important applications in this area is in the batteries. The batteries of these days are possible with thanks to nanotechnology. Also the supercapacitors. Thanks to the supercapacitors, we can make a lot of wearables, a lot of technology, computers, smartwatches, and the nanotechnology is in every device that you can have. Also, another application is in photovoltaics, thin fields and quantum dots, nano perovskites. Summary, these are used in solar cells. Thanks to nanotechnology, we can approach the solar light in a better way, making more efficient these solar cells and in all the photovoltaic area. And the last one for remediation, thanks to nanoparticles of titanium dioxide are used in photocatalysis. And also in the filtrations, we can make membranes with nanotechnology that help us to filtrate water. Okay, the last application that we're gonna see in this presentation is materials and electronics. Starting with nanocomposites. There are polymers reinforced with graphene or nanotubes, and it make it lighter and stronger. They have very good properties to everything. Also, we have coatings, scratch resistant, hydrophobic, antimicrobial surfaces. They are very used in the automotive industries. And last one is in electronics. We have very small transistors, and thanks to that we can make most smaller devices, and smaller transistors, smaller devices, we can make smaller devices. And also we have the ultra sensitive MEMS sensors. These sensors is the sensor that use the glucometer that previously we said that is one application in health. Also worked with this electronic. Okay, with all the things that I just said, we can know the where the nanotechnology is in all the market and the trends of the world. Thanks to the nanotechnology, we can have a lot of things that we use every day. We have flexible electronics, wearables are growing very fast. Also in medicine, personalized medicine, diagnosis plus therapy, they are used in the hospitals, they are in everywhere. Also in the artificial intelligence and automatization are speeding up this discovery of materials and the optimization of these materials. The nanotechnology is gonna be is the future, is the present and the future. It's in everywhere, and that's gonna be in everywhere. And in conclusion, I just wanna say that nanotechnology is already in our products, and it will keep expanding. It's very used. Most people think that is the very futurist technology, but now it's already in your products. It's very used, and it's the future, and it's very used in every product of technology that we have on our houses. And I hope with this presentation you can know a little bit about nanotechnology and the importance of the nanotechnology in this world. Thank you.